according to Black-Scholes, we have 5 variables that determines the option value. Current market price, denoted as S. Exercise price, denoted as E. Interest rates or cost of fund, denoted as R. Risk of volatility. Can you see those important things of that asset? There's a risk attached to this asset now. There's a risk that the price will change. There's a probability that things will not go as planned. Then time to expiry. Time is very important. Time value of money is very important in financial management. If I want to buy something in 4 months' time, I need to know or have an idea of the price or costs of that asset. It is a basic information. Exercise price. How much is that future price? So the exercise price is important in valuing the option. Number 3, the interest rate. This is the cost of fund. It is the opportunity cost, implying that if I don't use my money for options, what else could I have used my money for? Risk, measured by standard deviation. This one indicates the volatility. You know what it means, something to be volatile, right? How does it react? How possible is it for prices to get worse? Time to expiry, very important. This is the option duration, e.g. 3 months, 6 months, 9 months, 1 year, etc. Now let's go to the formula. What is this thing you always see it in your ICAN exam question at the back. So the value of a call option. Now, you don't forget that option can be call option or put option. You can have a call option or you can have a put option. Call option is when you want to buy, very common. And this is when you want to sell an asset. Call option is equal to S. When you see S, what does it mean? Current market price. Remember, we've talked about it here. So S times ND1 minus ND2 multiplied by E multiplied by small e minus RT. Everything has a meaning. So C is the value of the call option. That's what we are looking for. That's the unknown. So S is the current market price. How much is this calculator in the market? You've gone to the market, you know it. The exercise price, how much did I tell you? That is it. R, the interest rate. It will be given. Okay. T is the time to expiry. They will also give it to you in the question. ND1. This is the probability of deviation from S. Let me explain. D1 is on its own. D1 is the deviation. D1 is the deviation from S. ND1 is now the probability where it will deviate. What is S? S is the current market price. Let's say this calculator is currently sold at, in the market, it's currently sold at, say, 1,500. So that's the current price. Exercise price, 2,000. We agreed that in the future, I'll sell it for you at 2,000. That is, you will buy at 2,000. Now, D1 is the probability of deviation from S. That is, that S, probability of deviation from S means that the price will deviate from what it usually is. They show it on the number line. Then ND1, when you now put N, I'll show you how to do this in the table. It is the probability that that deviation will actually occur. So you have the question on the screen. Question 1. Consider an option to purchase an ordinary share in Lawrence PLC at 65 kobo. 65 kobo is the what? Exercise price. The price you will buy that share in the future. So they're telling you to consider the option, meaning what? To value that option. Is it worth it? When the price of the share is 62.5 kobo. So current market price is 62.5 kobo. The option will expire in 4 months. So you are holding that option for just 4 months. That is T. The volatility of Lawrence PLC shares as measured by the standard deviation of the return on the shares for the 4-month period to expiry is estimated to be 40%. All these long stories just to tell us that standard deviation, risk, remember, is 40%. Calculate the price of an European call option premium and put call parity using the Black-Scholes option pricing model. Knowledge gap is a big deal because you can see this question in the exam, and because you have no idea or you did not watch the previous class, the one before this, you would not know how to solve this question, and it could be 15 marks attached to it. So what did they ask you to do? Calculate the price of this call option, meaning value the call option and the put option. Price of option, because that's what they call it, right? So the call option. What is the formula to calculate the call option? C equals S multiplied by ND1 minus ND2 multiplied by E minus RT. raised to power minus RT. So once you write out your formula, you start to define the variables. C is the unknown. What is S? S is your current market price, and it was given in the question as 62.5 kobo. So one share is selling for 62.5 kobo in Lawrence PLC, but somebody wants to buy it in 4 months' time, and he wants to enter an agreement. And even if they are selling it at 100 kobo by that time, I'll buy it at 65 kobo. The right to buy it at this price. Now, what is ND1? You don't know, because this one has a formula of its own. You go and get it. E, that is a calculator function. What is R? The risk-free rate, which was given to you as 5%. What is T? He said it's 4 months. Time to expiry, 4 months. Now, in option pricing, value it in years. Always put your months in years. So this is going to be 4/12, right? That's 0.333 years. How did I get this? 12 months is equal to 1 year. So now, 4 months, because we want it in years, is equal to how many years? You don't know. So since you don't know, you cross multiply. 4 times 1 divided by 12, right? So now I've got 4/12 years, 0.33. Put it in your calculator. So this one is just by the way. In the question, they also told us the standard deviation is 40%. You need the standard deviation when you're trying to get your ND1 and ND2. So since we don't know ND1 and ND2, we go and solve it. ND1, what's the formula for ND1? It's always given in your exam question at the back. Ln S/E plus R plus 0.5 standard deviation square T all over standard deviation root T. So this is the formula for ND1. All you need to do is put in those variables and you get your ND1. So we have natural log. What is S? 62.5 kobo. The price is correctly selling. The future price that we want to agree, 65 kobo. Plus, what is R? 5%. 5%, or you can just write 0.05. Is it clear? Plus 0.5. This 0.5 is in the formula. 0.5. What is your standard deviation? The risk, 40%. That is 0.4, right? See, we are following this formula. Multiplied by 0.4 raised to power 2. Close bracket. T. T is 0.333, or just say 4/12 to make it easier. All over standard deviation 0.4 root T. Carry your calculator, because we're in a very important stage. You can make a mistake here, and then, you will just get everything wrong. The way you're going to start solving this is to take this as 1 and take this as 1, and this is the third one. So put in your calculator 62.5 divided by 65. 62.5 divided by 65, you get a particular figure. Then you go to your natural log. It's somewhere around here. Your natural log is here on the third button. You see it's ln, that's what it's called. You just press it, ln, answer. Makes it easier. You have minus 0.03922. So you write that there. Minus 0.0392. Four numbers after the decimal is okay. You don't have to write out all the numbers. And don't make a mistake. There's a difference between minus 0.392 and minus 0.0392. Okay. So you dismantle this. Plus, so we have 0.05 plus 0.5 times 0.4 square. So let's start from this, because here is multiplication. And in your rule of BODMAS, multiplication comes before addition. So we dismantle this, then add to this, then multiply by this, because this is in the brackets. So we finish everything here first. But even inside here, we have to finish this first, because I've seen people solve this way. They will add this plus this, then multiply by this. They will get a different answer, and it will just give you a wrong value when you're trying to apply your call option. Okay, so those mistakes, you have to take note of them. 0.4 square, that's where we start from. 0.4 raised to power 2. 0.4 raised to power 2, that's square, will give you this. Then you multiply by 0.5 times 0.5, you get this. Then you add to 0.05 plus 0.05, then you get this. Then you multiply by 0.333 times 0.333, you get this. So your answer is 0.04329. 433 is enough. Let's just continue. All over the denominator, you can just say 0.4 roots 0.333. So you have 0.2308 minus minus 0 points. Okay, so point and 0 point still the same. Minus 0.03. Just write everything out in full. Minus 0.0392 plus 0.04329 equals this, divided by 0.2308. Look at your answer. Your D1, don't forget that we're trying to get D1. Okay, we are looking for ND1, but D1 is equal to this. It's true the table value will now get ND1. So this formula I gave you is the formula for D1. We've talked about it, right? Before even solving question. So it's your formula for D1. So D1 final answer is what? 0.0177. Now to get your ND1, that's where you need your table value. And this is the rule. ND1 is equal to 0.5 plus or minus table value. If that table value is greater than 0, that's when you use plus. If it is less than 0, that's when you use minus. So let's open our normal distribution table. That's what it is called. It is usually at the back of your question. So you now ask yourself, what is unknown here? Table value. How would I get the table value? D1 will help me to get the table value. So I'll take this D1 into my normal distribution table to get the table value. I'll say 0.0 under 0.01. So it's always the first two, 0.0, right, under 0.01. So I'll put it on the screen. You look at 0.0 under 0.01. Vertically, you have all those numbers, 0.0 down. Then horizontally, you can see all those values, 0.00, 0.01, 0.02. So you say 0.0, that's vertically. You can see where 0.0 is. Now look at where it intersects with 0.01. If you check it, you see that the value you have at that intersection is 0.0040. Okay, so what you are saying is something like 0.0040. This 0.0040 and 0.0040, they are the same. When you say this thing is the same thing, you just remove the 0 because 0 holds no value. So this is our table value. Does it make sense? You now bring that table value here and say ND1 is equal to 0.5. Are we going to use plus or minus? We are going to use plus. Why are we going to use plus? Because our D1 is greater than 0. Can you see? 0.0017 is greater than 0. Anything that is less than 0 will be a negative. So imagine if you had 0.9 minus 0.9. Can you see that it's less than 0? This is a number line. 0 is here. You can see the normal distribution thing. Anything on this left side is negative. Anything less than 0 is the one stealing from 0. It's negative. Does it make sense? So, since our D1 is greater than 0, we'll use plus. So plus, what is the table value we got? Now we got from this table 0.004. So should we say 0.0040? You would have 0.5 plus 0.0040, and that will give you right? And that will give you 0.5040. Okay, 0.5040, approximately 0.504. 3 decimal points is fine. So that is your ND1. We have all this. We don't have ND2, so we're going to find ND2. This is the formula to find D1 and ND1. Now let's do for D2 and ND2. Now we want to look for ND2. We need to start with D2 first. The formula for D2 is D1 minus standard deviation root T. That formula, deviation root T. Can you see? So to even get D2, you have to get your D1. And don't forget that we got our D1 to be 0.017. Yeah, 0.017 minus, what is our standard deviation? 40% root T, 0.333. Right? Remember that. So you have your D2 to be equal to 0.017 minus. Okay. You know why I'll pause there? Look at the calculator I'm using. It's not natural display. If it was natural, I would have put in this. So don't go and put 0.017 minus this. You'll get something. You're now going to multiply. No. we finish this first because this one is a multiplication. This is multiplication that is here. That is not showing, it's multiplication. And in the rule of board maths, see, you multiply before you subtract. Does it make sense? So you pause at that point. If you don't want to pause, you can use a bracket to separate it. Okay, so let's just do 0.4. For the people that are not too mathematics inclined, 0.4 root 0.333. You have your answer. So that's 0.017 minus 0.2308. Since we have gotten that 0.2308 as our we can now say 0.017 minus answer. And that will give us minus, can you see, minus 0.2138. D2 equals minus 0.2138. This is our D2. Thank God it's a negative, so we can demonstrate the other part of it. So our ND2, the standard formula, 0.5 plus or minus table value, depending on whether D2 is greater than 0 or less than 0. So you go to your table value. Formula guides you. When you write down your formula, look at how we wrote down our formula. Then start picking the variables. So you can't just start from the middle. Let me start from calculating D1. What is your formula? Then it will start guiding you. Can you see? So when you know this formula now, you now say, okay, what is my table value? That's the thing that is missing. So you use your D2 to go and get your table value. So get to your normal distribution table, which you can see on the screen. 0.2. Can you see? We pick the first two. 0.2. The former one was 0.0. This one is 0.2 under 0.01. Oh, it's not 0.21. 0.2. That's the first thing you can see. So you want to pick the third digit now. You're actually trying to pick this third digit. So ignore this 2 that is here. Just call it 0.01. If you want to pick the next digit, it's 0.003. I don't know if you understand. That's not important. Oh, that's not important. You want to even see 0.21 on your normal distribution table, right? You see 0.2 on the vertical side and 0.01, 02, 03, 04. So what we need here is 0.2. Check it. I've located the 0.2 line under 0.01. At what point did they intersect? What's the number there? 0.0832. So we come and write it down here. 0.0832. That means 0.0832. So we have 0.5. Don't go and mistakenly write plus. It's a minus. Why? Because this D2 is less than 0. So you write minus. It makes sense. Put this in your calculator. You have 0.5 minus 0.0832. And that will give you 0.4168. So your ND2 is equal to 0.4168. Now you've gotten all your variables. I didn't write the value for this. I think we got 0.504. Yeah, 504. Then for this we have 0.4168. Okay. So we can clean this because we're using the board, of course. So your notes you don't clean. So now that we've gotten all the variables, we can then put it in the formula and calculate. So your C, which is what they asked you to solve, don't forget, if you stop at ND1 and ND2, you've not gotten your marks. You've not even gotten half of your marks. C equals, what is your S? 62.5. What is ND1? Multiplied by 0.504. You see, this is so interesting that the meaning of this formula is that you're discounting this value. Because this is a monetary value. This is a discounting value. This is you discounting a future value. And that's even the essence of this exponential stuff that your lecturer might not be able to tell you in class because of time, of course. Minus ND2. You can start from E, okay? But this arrangement is just for ease. It's still multiplication we have here. It's still multiplication we have here. So ND2, 0.4168 multiplied by E. Let's discount this E, 65. Multiplied by, so we have E, I'll show you where it's on your calculator, raised to power minus R. What is our R? 5%, that's 0.05. Multiplied by T, 4 months, that's 0.333. So let us put all this one in the brackets for arrangement. So this one is straightforward, 62.5 times 0.504. 62.5 multiplied by 0.504. That will give you 31.5. Minus, let's restart from here. Let's start from this one. When we simplify this, then we find the exponential. So we say minus 0.05. Minus, because this minus is together with this, right? It's very important. Don't lose that minus. Look at it. It's coming with the formula e raised to power minus RT. You know this R is not coming with its own minus, but this e is carrying a minus on top, so don't misplace it. It's the same thing as 1 over e raised to power RT. Remember that our index is x raised to power minus y is equal to 1 over x raised to power y. So that minus is important because, let me try and show you the difference, or let me just say that if you remove that minus, it will affect the answer. So minus 0.05 multiplied by 0.333 minus this. So you pick your e, you've gotten the answer of what is at the top. Now you need to incorporate this exponential, that e. Just press shift, natural log. That's what e is, shift, natural log, answer. That is e raised to power this answer that you've gotten. See where your answer is here. Then press equal to. Can you see what you got? 0.9834. 0.983348. That's 35 multiplied by 65 multiplied by 0.4168. Let me show you if you remove the minus. 0.05 multiplied by 0.33. Can you see? Shift e raised to power answer. You're having 1 point. 1 point instead of 0.9. You're having something greater than 1. Can you see that it is different? If you put that 1 point here, you have scattered the whole answer. So what is simple things is where the complication of the question is. So now that everything is on the same level, multiplication, just multiply straight, right? So we have 0.4168 multiplied by 65 multiplied by 0.9835, and that will give you 26.6. 26.64. Let's call it 26.6. So C equals 31.5 minus 26.6. That's all. So 31.5 minus answer, and that will give us 4.8 kobo. So the value of this call option is 4.8 kobo. You that you're thinking about it, they told you that a share is cost 62.5 today. In the future, you will buy it for this. So the person that is holding that option, that call option, is it a gain or loss? Looking at it from today's point of view. You watching this video, they told you that today this thing is called 62 points. This thing is valued at 62.5. But tomorrow, this is today. Tomorrow, in future, you will have to pay 65 for it. Is it not like a loss? If it's going down by, it will be like a gain. Can you see the power of discounting? As at the time we discounted, we take into consideration interest rates, very important key, standard deviation, time. It looks like a negative if you are comparing today's value or the future value. But when you discount the future value, look at how worthless. Not worthless, but look at how low it can look, right? Because inflation has been involved, times have changed, and all those things. Now, they also have to get the put call parity. So you say the value of the call option is 44.8 kobo. They didn't ask you to make any comments. But it said you should calculate the put call parity, which is the put option, which is what represents the value of the option to the seller. So we recall our put call parity option, which is equal to C plus E, which is equal to C plus E minus RT equals S plus P. Please let me confirm this for my formula because I'm not sure. It's correct. It's correct. Yeah, that's the put call parity option. C plus E ART equals S plus P. So what we are looking for is this P, the put option, because you already know all of this now. Very simple. So you make this one the subject of formula. You make P subject of formula. That means P equals C plus EERT minus S. It's simple. So what is C? 4.8 kobo. 4.8 kobo. Plus what is E? 65 kobo, right? Times E raised to power minus RT minus RT 0.05 times T 0.333 minus S. What is S? 62.5 kobo. 62.5 kobo. That's our put call parity. So that will be 4.8 plus, no, we have done this here. We have simplified this thing here. So let's just get what 65 times this is. 65 times 0.9835. That will give us 63.928 minus 62.5. So minus 62.5 plus 4.85. Can you see? The put option is what? 6.2775, approximately 6.3 kobo. Everybody is fine, everybody is gaining. 6.3 kobo is the value of the option to the seller. This is the value of the option to the holder. Put, call, to buy, to sell. Right? So this person that is buying is the holder. This one that is selling is the writer. This one that wants to buy the shares and he has valued that option. It's not that it's a positive of 4.8 kobo. This one on the other hand, seeing it as a positive of 6.3 kobo. Everybody is fine, right? Should we solve another question now?